Good morning, everybody, and welcome back to Next Door NetAdmin. Got an interesting comment last week. Corey PL saw the video about adding disks to my NAS at home and asked, do you rebalance your ZFS pool so that you get the full performance of the disks back? The short answer was no, I don't. But the more I thought about it, the more I realized there's a whole lot of explanation there that is better off as an actual video where I can explain it rather than a comment, which would go on and on and on, kind of like my videos do. So let's talk about rebalancing ZFS. First of all, what is it? What even is this term? If you look in the ZFS literature, there's no command labeled rebalance. So what is it that we're talking about here? Conceptually, when you have a series of vdevs in your ZFS pool, all of the writes are written in proportion to how much free disk space they have. For simplicity's sake, I'm going to use an example where we're using vdevs with equal capacity. And note that I'm talking about vdevs here. I'm not talking about individual disks, because at this level, ZFS is working with vdevs. It doesn't matter if it's a mirrored pair or whether it's a set of, 3 disks in RAID Z1. Conceptually, we're only looking at vdevs. So let's say for my example, I've got one vdev of 8 terabytes and a second vdev of 8 terabytes. With me so far? Cool. As we write data to the pool, the writes will be split 50-50. Starting from empty, we'll just fill these up bit by bit, splitting each write by block. You can conceive of it, it'll technically be by quite a few blocks, but we're going to split these writes 50-50 over our 2 vdevs. Okay. Over time, these have grown to 80% full. We only have 20% free space left. And when we reach the 80% threshold, we go, okay, obviously I need to expand this pool. So we've got one vdev, 80% full, one vdev, 80% full, and then we're going to add a third vdev over here that is empty. It's also 8 terabytes in size, but it is empty, brand new. If we write data now, ZFS is going to look at this proportionally and say, okay, this vdev here has 20% free. This vdev has 20% free. This vdev has 100% free. So I'm going to put one block here, and 5 blocks over here, because that's the proportion, 20, 20, 100. 1, 1, 5. So what you've got then is these disks will have, these vdevs will have comparatively fewer writes and consequently fewer reads for newly written data than this vdev over here. You're going to end up bottlenecking, or the risk is there that you could bottleneck this brand new vdev because it has to do the bulk of the writing from now on, because we're trying to keep things in proportion. And you might say, this seems clearly suboptimal. If I add a brand new vdev, why don't I just move the data over here? Because ZFS doesn't work that way. Whereas in a traditional RAID setup, you might have to keep the disks identical for best performance, or else the controller is going to work extra hard at it. With ZFS, because at your top level, it's just a stripe across vdevs, and all the complex stuff happens inside the vdevs. you might have a single vdev that is 2 mirrored disks. Okay. You might have a vdev that is a RAID Z1. You might have another vdev which is mirrored, but across 4 disks. Again, the administrator is free to choose whatever setup they want for the individual vdevs. ZFS at the pool level does not need to worry about this. It just stripes the data across the vdevs. And then each vdev has its own architecture that the administrator has defined. So it doesn't know about splitting data equally among these disks. These disks are separate things, and they can be of differing capacities. If you've got 2 8-terabyte arrays, or excuse me, 2 8-terabyte vdevs, and you add a 16-terabyte, that's relatively easy to calculate. You want to put twice as much data on the 16 as you do on the 8s. But what if it's a 14? You can still figure it out if you want to do the math, but all of this moving things back and forth is more time that the array is shifting data around, and there's no automated process for doing it because it's complexity that is, for some people, viewed as unnecessary. And for some people, it's viewed as, this is just how it should work. Okay, let's say that this is what we think we should do. We should rebalance this so that all of our vdevs, again, in our example, they're all the same size, they're all utilized to the same degree. So instead of 80%, 80%, 0%, we want them all to be around 33%, give or take. So we've got to move a bunch of data over here. The traditional way, if you really, really feel like this is something you need to do, is actually to create a second pool. And you send the entire contents of your pool to the other pool. It can be on the same disks if you have enough free space to create another pool. And then you destroy your original pool and send all the data back. This seems like a lot of effort. And you essentially need to have enough hardware that you can double the entire space of your array, because you need to send the entire pool elsewhere, get rid of the original, and then bring it back. Why would you have to do this? Is there no way that you can do it in place? An in-place rebalancing. You can, but it's not as simple as you might think. Conceptually, we know we want to move the data from one place to another. But if we think about how ZFS works, that's not how ZFS works. ZFS is a copy on write file system. If you are moving data, you're not actually moving it within the file system. At the file system level, a move is just updating the index entry of where the data is. The blocks aren't changing. And so if you're within the same file system, move doesn't move anything. It doesn't copy it anywhere. There's no data being written. It's just updating the directory index that points to these blocks. And so moving data around on the disk is not going to do anything unless you're doing it in particular ways, such as via copy. What you really want to do is copy the data to a new copy so that with a copy on write, you're making it write something with a copy, then you delete the old and you rename the copy back to what the old one was. If you do that, the copy, again, you'll have 1 block here, 1 block here, and 5 over here. So more of your data is going to be written to the new disk, and the proportion will change every time you copy something over there, delete the original, and then you copy more and delete that original. Okay, conceptually, this works. It's a lot of effort, but it works. Unless you have snapshots. If you have a snapshot, every time you've created a snapshot, you're taking, you're essentially locking that block and saying, I'm not going to change this block, it's referenced by a snapshot. So every new write is going to go to something different anyway. And if you were to delete that file completely, it's not gone from disk because it's still referenced in a snapshot. So it's going to hang on to this block and it's not actually going to free it. So if you want to rebalance this, if you have snapshots, you're not actually going to do anything except consume more disk space because it has to hang on to these blocks in the snapshot. That's what the snapshot's for. That's how it functions. So if you're like me and you have quite a few snapshots because you want to be able to reach back in time, if you realize, 2 months down the road, oh, where'd this file go? I thought I had a file here. When did that disappear? It's not a file I look at every day. When did that go away? And you find out, oh, I must have accidentally deleted it 2 months in the past. A snapshot's a great way of immediately being able to look back and go, here, I want this file back, thank you. Without having to go through your cloud backup, because you do have a cloud backup off-site, right? Without having to go through your cloud backup and try and figure out how to pull that back down easily. You can just go through your snapshot. Okay, well, if I do this rebalancing thing, in order to make it work, I'm going to have to get rid of all my snapshots so that when I delete something, it actually deletes and I can slowly shift the level of data by copying and then deleting and then renaming every single file in my pool one by one. That's a lot of effort to go to, and it requires that I sacrifice all of my snapshots. No more previous versions. We're just going to reset everything to what it is today, and if I need something, I guess I'm stuck going through my cloud backup for as long as that's around. That's somewhat suboptimal as well. If you were doing a send of the entire pool to another device, the snapshots go with it. And if you then delete the original pool and send it back, it's rewriting all of that incoming data, including the snapshot data, and it's filling all of your vdevs evenly again, including with the snapshotted data. So you can keep your snapshots if you're sending your entire pool somewhere else and then bringing it back. If you're doing an in-place rebalancing, it's not going to work as long as you have those snapshots. Let's think about this in a different way. Let's say you don't rebalance your array. What happens over time? Well, over time, like I said, you still have your 2 8 terabyte vdevs here. They're only going to get 1 block, roughly, each, while you're putting 5 over here. But over time, your snapshots are going to age out. And when a snapshot ages out, it's going to preferentially release data on the 2 vdevs that have the oldest data, because that's where the snapshotted data was. Every time one of those snapshots is released, it's freeing data on these 2 vdevs, whereas all your incoming writes are still going to be biased to your new vdev. So over time, as your snapshots age out, your array is going to rebalance itself anyway. It's just going to do it over time. So how about this loss of performance in the meantime? Exactly how much it affects you is going to be down to your personal use case, obviously. If you're only writing data every now and then, you're probably not going to notice a whole lot of impact. If you're writing a lot of data, you might say, well, I'm writing gigs and gigs of data, and this is absolutely going to become a bottleneck. I should rebalance this. I would argue that before you look at rebalancing, you should probably prioritize a separate log device. The device type is called log. You can also hear it referred to as the ZIL, the ZFS intent log. You might even hear it referred to as SLOG because it is separate log device. From last week when I talked about file systems, I said you have a journaled file system where first it writes all of the incoming data to a journal before it commits it to the actual data structure on disk. So that if you have a power loss while you're writing the journal, then you haven't corrupted your file system. And if you have a data loss while you're writing the file system, you have a log that you can go back through and replay all of the writes to make sure that everything is consistent when you're done. ZFS has something similar. It's called the ZFS intent log. It works in the same way. As writes come in, they're written to the log first before they are written to the main disk. Now, if you have spinning media, this essentially means that you're incurring your slow writes twice, because you have to write all of your incoming data to the log on disk, and then you have to rewrite everything a second time to the actual data structures in your pool. That's where it can get really, really noticeable if you're doing this double write and you're doing a lot of writes. And this is true whether your array is balanced or unbalanced, but if it's unbalanced because you've added new vdevs, you're going to really notice it. But if you have a separate log device, something fast, a really good SSD, for example, then your log is always being written to the SSD. And then every 5 seconds or every 16 gigabytes of incoming data, whichever comes first, it will flush those writes from the log to your spinning media. But your performance that you see will be just to the SSD, because you're only writing to the log device, and then ZFS says, okay, I've got a solid copy of the incoming data. I will write this out to the disks on my own. I will manage that. I can tell the user that his data is safe, and he can move on. If you have a separate log device, you get the benefit of this speed increase whether your array is balanced or unbalanced, because you don't have to wait for it to be written to spinning media. You just have the SSD and you move on. And with larger arrays where you need the cost per terabyte of spinning media as opposed to the cost per terabyte of flash media, you can still have a write accelerator or a SLOG that can handle and can accept your incoming writes at speed, and then it can write it out to spinning media, and the user doesn't have to worry about the performance impact because it went to SSD first. I would argue that it probably makes sense, and you'll see more benefit if you're worried about the performance. You'll see more benefit from adding a separate log device before you see a significant benefit from rebalancing your pool and having to sacrifice all of your snapshots into the bargain. If you have that, great, then it speeds it all up. If you don't have a separate log device, or you can't add a separate log device because you've already used all of the disk slots in your chassis for vdevs, for data vdevs. Okay, then maybe if you really need the performance, you can't add a slog, and you're willing to sacrifice your snapshots, maybe it's worth it for you in that one instance. Blow away all your snapshots, spend your time copying files, deleting them, renaming them, and if that makes sense for you, then that makes sense for you. For me, personally, that doesn't make sense. I don't use my home NAS enough, and I'm not worried enough about it to say, hey, I really need the performance increase. I really need this to the degree that I either need a slog or that I feel like I need to blow away all my snapshots and lose the benefit of them in order to be able to rebalance my pool. For me, it doesn't make sense. For some of you, maybe it does. And the wonderful thing about ZFS in this regard is that it's flexible enough that you can do what you feel you need to do. Cool. The tools are there if you want to use them. But for most home users, do I think that rebalancing is necessary? Probably not. That's my opinion. But a big thank you to Corey for popping that question up, because that's given us an opportunity to discuss this and think about it and hopefully learn together. If you have any other questions, or if you have things that you'd like to hear me talk about, feel free to let me know right down there in the comments section. Otherwise, thank you very much for watching. I am your Next Door NetAdmin, and we will see you next time.